Okay, we're looking at section 7.1a, and what this section is about is it's introducing fractions, and basically the idea is that you look at the denominator and you say, okay, I know that in mathematics I cannot divide by 0, okay, and maybe you aren't aware of that as a rule, that if I take 0 and I divide it by something like 0/6 or something like that, that's 0. But if I were to flip that and I would have 6/0, you can't have that. That's undefined. It approaches positive or negative infinity. So it's not actually a number. And so when you look at something like this, when they're talking about defining rational expressions, rational talking about fractional here, uh, they're saying, look at the bottom and tell me what x can't be, because if I were to plug in that particular x value, I would end up with 0 on the bottom. So notice what we have here. I mean, 0 on the top is okay, right? If I plugged in 9, I'd have 9 here and 9 here, and I'd work it all out on the bottom. I'd get, some number, but 9 take away 9 would be 0, no problem. I'd have 0 on top. But what are the things that it wouldn't take to plug in to get 0 on the bottom? Well, that's where the steps that we've actually already talked about in section 6.4 come into play, where you take x squared plus 6x plus 8, you factor it, and then you think about, okay, what are technically the solutions to those factors if each one were set equal to 0? So it's very much like section 6.4, but you're focused on the bottom of the fraction and solving for restrictions, not for solutions. So with this problem here, let's see how the tutor mode goes about doing it. Basically, if you're fairly comfortable with the things we've talked about in the past, you'd probably see how you could factor this pretty quickly on the bottom. X squared plus 6x plus 8. So let's see. They say a variable in a rational expression is restricted to values that will not yield a 0 in the denominator. Since division by 0 is undefined, the value of the denominator of a rational expression cannot equal to 0. We can determine these values by setting the denominator equal to 0 and solving for x. So they say set the denominator of a given rational expression equal to 0. So they're just making sure that you do indeed know what a denominator is. That's the bottom of the fraction. Okay. So that's the first step, is to think about, okay, what would make that 0? They say the denominator can be factored into two variable factors. Determine the denominator, factor the denominator, and set the two factors equal to 0. So remember the process. When there's just a 1 out front, and you can't pull anything out that's common, all that, and it's just a 1 out front, you could say, you could say, look at the last number and say, can I think of two numbers that multiply to give me 8 and add up to 6? These were the really quick ones. So, it's a plus plus scenario, so it's two positive numbers. It's either 1 and 8 or 2 and 4. Definitely 2 and 4 add up to 6. So we're going to type in a set of parentheses here if they'll let me. Well, I guess I don't want parentheses. So we're assuming there's parentheses when you factor. They don't want to bother showing it, but I would. X plus 2, x plus 4. That's what you'd have for the combination. And when you solve it out, you have two solutions here. So I believe what they want me to do is to type in, when I solve each little equation, I'd have -2 and -4. So if I type in -2, I can do a little comma. I can do a -4, and that will communicate that those are my two restrictions. If I were to plug either one of those numbers in back to the original, I'd end up with 0 on the bottom in either case, and we don't want that to happen. So those are our restrictions. Okay, another example. You may recall from section 6.4 that I tried to find one of these types because I said a lot of times people get confused and try to apply some of the trinomial factoring to this. In reality, if you have 6x squared minus 7x, constant tacked onto the end, they have an x in common. You pull out the greatest common factor, you've just immediately factored it. Okay, so if I go to tutor mode, they're going to ask us the same type of thing. Previous question asked this first where we said, what is the denominator? Set it equal to 0. And then they say there's two factors. Well, in this case, I pulled out an x, so I'll set that equal to 0. And if you factor out an x, what you'll have left inside the parentheses, which I can't really show you here, but imagine you pull out an x, and left inside the parentheses you would have 6x minus 7. When you divide it away, 6x minus 7 goes in the other set. And with each one set equal to 0, when you solve, the first one is 0. There's nothing to say further than that, because x is already by itself. The second one gives us, if we add 7 to both sides, divide both sides by 6, you're going to get a fraction. Then let me type that in. There we go. You're going to get a 7 over 6. Okay. What about this one? If you had x squared minus 9 on the bottom, how would you go about factoring that? Well, I'd say this is fitting that special pattern of the difference of squares, right? X squared take away 3 squared. So remember that it was the square roots of each of those pieces in a plus-minus pattern. So we can check it out in the tutor mode. X squared take away 9. The factors, the square roots of those pieces with a plus or minus pattern going on. X plus 3, x minus 3. So we've got x plus 3, x minus 3. Are going to give us, if you subtract 3 from both sides, a negative 3. If you add 3 to both sides, positive 3. So negative 3 and 3 are your solutions. Okay. So here's another one with a trinomial on the bottom. I'm going to be pushing 10 minutes here on this video, so I'll try to squeeze this one in. Here's the bottom. X squared minus 4x plus 3. Okay. Remember that the factors, two numbers that multiply to give us 3 and add up to a minus 4, are going to work on this example. It's a minus plus, which is a scenario that really, ends up being a minus minus, and minus 1 minus 3. The only combination that makes sense to multiply to give you 3 and add up to a minus 4. So if you have x minus 1 equals 0, add 1 to both sides, you get 1. Over here, add 3 to both sides, you get 3. Those are your restrictions.